Okay, so we're all here in the shop now, and I have my meter. I have my red lead and my black lead. I'm going to hook black to black, red to red, turn it on to DC volts, and I can see I have a static voltage of 12.75 volts. Now that number could move around just a little bit. I might see 12.8, 12.5. As soon as you get done running the machine, it might be 13.2, things like this. So I'm sitting there at 12.75. Now, I'm going to start the machine up with no load, and I'm just going to let it sit at an idle, and let's see what we got. Okay, we've shut the machine off and we're sitting at about 12.8. Now remember we had about 12.75 before. Actually, when we first shut the machine off, we had closer to 13 and it slid down to a 12.8. It'll settle down to about 12.75. That is just a stabilization of the battery. That does not sit, you can't say that my battery is discharging or it's going dead. So this was static voltage, charging at idle, charging at high idle. Next thing we're going to do is we're going to start the machine up and we're going to load this thing up with everything it has. Wipers, air conditioning, blower motor, lights, wipers, you name it. Whatever the machine has on it, we're going to turn it on. Okay, so all we just did is we started the tractor up, we had our voltmeter on, already on the battery, and I loaded up the system. I turned on front lights, I turned on rear lights, I turned on wipers and four-way flashers. And we saw that it only came down about 14.29, 14.3 volts. And the one thing you may have noticed, it wasn't steady. It turned on and off, or it flickered back and forth. It wasn't stable because my load was changing. What was changing? My flashers were on. So as the flashing lights came on, that put more load on. My voltage may have come down by just a scooch, and my lights turned off when was the four-way action. My voltage would have came up a little bit. So that's just a fluctuating load. It is entirely normal. But the key is my charging system stayed up with all my loads well above my static voltage, which means my charging system is able to keep up with all loads installed on my tractor. Okay, so here we are. I have my inductive amp clamp hooked around my positive post. Now notice I have it around two cables. That's because that smaller of the two black cables goes to my engine controller separately, and the bigger cable goes into the rest of the machine. If I only clamped it on one clamp or one cable, I would only be measuring out of what comes out of that cable. And I want to measure what's coming out of the whole battery, key off, sorry, not key off, I'm going to measure engine off. What is my load coming out of my battery that I'm putting on my system without charging my system. So in other words, I have that water tower, I'm turning all the taps on in my town without pumping the water tower up. So I'm going to key on, you're going to hear the buzzer. There's the key on. Now most of that is going to my engine controller right there, about 17.3 amps, something like that. It's going to hang around 17. Now as I turn on my four-way flashers, there's front wipers, and I'm going to turn my rear wipers, and I'm going to turn on my heat blower motor and my air conditioner. And I'm running about 40, I'm running averaging about 40 amps. Now in this particular model, I can't turn my lights on without the engine running, so we're not going to see that load. But this gives me an idea where I'm starting from as far as what is my load on my system when I'm not charging. In other words, I need to have a charging system to be able to sustain this kind of load. Now, it's fluctuating around a little bit. I'm going to turn my four-way flashers off, and it's still going to move around a little bit because essentially what I have is wipers going, and their loads change a little bit. We turn the front wipers off. I'm going to turn the rear wipers off, and there is about 28 amps. All I have is my engine controller and my blower fan and my air conditioning clutch is really all it's on. Blower fan, air conditioning clutch went off at the same time, and I'm back to my engine controller. I'm going to key off, and I'm going to go essentially back to 0. Now if I zeroed my meter out, it would go back to 0. That little bit right there I'm not really worried about yet. That is key off amp draw. That it's a whole nother set of tests there, a whole nother video for that. Okay, now I have my amp clamp hooked up to my alternator only around the charging wire, and I can see that I'm running about 0.6. I might be running 0.2, 0.3 amps. I'm not worried about those small potatoes, okay? So we're worried about the bigger stuff. That's some phantom amperage running around. I'm not worried about that. Now I'm going to start my machine up. And right away I'm going to be charging very high. You notice that I'm running, it was about 80 or so, 79. It came down about 50 very quickly. That's entirely normal. That's recovering into the battery or the water tower, if you will. I'm pumping to recover from my cranking amperage. So I'm sitting here about 39. If I sit here and run it longer, it'll probably come down to about 30. Now remember, this is everything coming out of the pump to supply my water tower, but there's some going into the system. So I'm sitting here about 35. I know my engine controller takes about 12 in itself, not counting everything else that might be running. My instrument clusters and everything else. So I'm going to load it up right now. There's hazard lights, front wipers, rear lights, front lights. Turn my heater on all the way. And I'm running up about 83 amps. That's with everything on. Now, the chances of having everything on for an extended period of time is not highly likely, but I'm running about 83 right now. Now, let's take and shut some lights off. There's my air conditioners running on high. It's not raining, so I'm going to shut my wipers off. And I'm running about 50 some amps, 50 amps. Hazards. And it stabilizes there at 47. That's just blower on high, and my air conditioner clutch is turned on. And that will continue to come down a little bit more even after we run it, because my water tower or my battery is going to be stabilized. Okay, now we've checked our amperage output of our alternator with it under loads of the machine, but we've never really checked what the alternator is capable of putting out, or as far as maximum output. The only real way to do that is to put a load on the system that will truly maximize out the alternator. So I've attached a carbon pile, a load tester, to the battery already. It should be done at the battery, not the alternator. I'm going to essentially load test the batteries, but I'm load testing the system while it's running. Essentially on my water tower, I am opening up the fire hydrants, every shower in town, everything I possibly can, and I'm just dumping out the water tower, and I'm seeing how fast my pump house can try to fill up the system. So I'm going to start the machine. There we see our 50, 60 amps like we did before. Now I'm going to go ahead and put a load on it. And I'm only going to put enough load on it until my alternator quits climbing. So I'm at 35. I'm going to put a load on it. It's going up. I don't want to get too crazy with it. Now I'm about 83, 84, 85 amps. That's all the alternator that I have, about 86 amps. Now I want to back that off because I don't really want to let it sit there too long. And if I look at my alternator, I see I have a 90 amp alternator. So that's about right. Now that I have all the load off my alternator, I'm going to shut my engine off. And we can evaluate our system. From AIS Training Center, I'm Steve Sutton.
And I'm Joe Thompson. Work smart and work safe.